Okay, hello there, and welcome to another one-on-one lesson, science. And today we're working on physics. We're working on physics now with Mr. An, and so it's my student, and we're working on learning activity 4.2, creating electric circuits. Electric circuits. Can you read that one? Current, electricity, something.
Current electricity. In the previous learning activity, we discussed how electric charge build up on surface to create static electricity. Now let's explore what happens when these electric charge continuously move in what is known as current
Current
electricity.
electricity.
Current electricity is the most useful form of electricity. Current electricity involves harnessing the energy of electricity when it flows through the conductor. The following diagram illustrates how electric current flow in a copper strip. As you can see, current is the flow of electron. The current that flow through circuits can be measured. The unit for measuring current is the ampere or amp. This indicates the amount of charge that passes a certain point in a circuit every second.
Current electricity involves harnessing the energy of electricity when it flows through conductors. The following diagram illustrates how electric current flows in a copper strip. As you can see, the current is the flow of electrons. The current that flows through circuits can be measured. The unit for measuring current is the ampere or amp.
Ampere.
This indicates the amount of charge that passes a certain point in a circuit every second.
Two types of currents. Depending on the direction of the moving electron, there are two types of current electricity: direct current (DC) and alternating current (AC). Make an educated guess at defining direct current (DC) and alternating current (AC). Predict how they might work. To do this, use your knowledge of electrons and their charge, wires, and conductor, and the word direct and alternating. How does a direct current work? Electrons with a negatively charged flow freely through conductor. Direct current means the current flows only in one direction, forward.
The electron will try to find another way to reach destination.
Yeah, destination.
Mm-hmm. Could keep changing between forward and backward. Be careful. You're answering the wrong one, I think. When one path conductor is blocked, the electron focus on the path to reach main point. That's not how That's not how AC works. Alternating means like it's go back and forth. So your answer is wrong. Even though it's true that electricity will do that, but it's not what AC. It's not how AC works. Have to see again.
Oh,
Alternating current means direction keep changing between forward movement and backward movement. It's changing like that, like continuously.
okay.
That's why it's called alternating current, AC. Direct current's like going one way, DC. Can I see your answer up there?
Yeah, sure.
Right. How does DC work? Flown readily through conductor direct current means flow only one direction forward. Be careful. DC direct current only means like it follows in one direction. That should be the answer. One path to reach its main goal. But your answer is kind of fine too. I like it. But about this AC, I don't agree.
Action. We can just read that. Direct and alternating current. Direct current. Direct current DC is the flow of electron in one direction. The most common source of DC are either a battery. Batteries are made of two or more electrochemical cell or an AC to DC adapter, sometimes called an AC/DC converter. Batteries have opposite charge of their terminals. One terminal has a positive charge, plus, and the other one has a negative charge, minus. Conventional current is defined as the flowing from the positive terminal of the battery toward the negative. We know the we now know current is caused when the electron moves from the negative terminal to the positive one. So the current is in fact opposite to the electron flow. Alternating current. The other kind of current electricity is alternating current, AC. It is the kind of current electricity supplied by wall outlets AC operate most applications, including light fixture, stove,
Refrigerator,
refrigerator.
TV, AC provide more current than DC because it just back forth. So basically, it flows many times to the object. It provides more current than DC. It's able to travel along the transmission line more efficiently. DC is only used for something like battery,
Yeah, battery.
but AC is much more used for like household objects because it provides more electricity, more flow, more current. Because they are more flowing through one object at one time. It's like a
In alternating current, the electrons change their direction of flow many times per second. In other words, electrons travel forward for a fraction of a second, stop and travel backward for an equivalent fraction of a second. In Canada, the standard is for the current to change 60 times per second. In parts of Europe, the standard is 50 times per second. For a better understanding of what you just read, watch the following video.
In direct current, the flow of electrons go in one direction. Electrons move from the negative terminal to the positive terminal. Current is described as flowing from the positive terminal of the battery towards the negative. So current and electron flow are actually opposite each other.
okay. Remember that.
In alternating current, the current changes direction periodically.
Okay, you must remember something. Electron is the electron that flows, right? So electron doesn't come from the negative side, going to the positive side, right? So electron flow from negative to the positive side or poles. But conventionally, we do it differently. So conventionally, we say that the current flow from positive to negative. So it's the opposite of the electron flow. Even though we know that the electron flows in the opposite one, but conventionally, it's a convention everyone agrees on already before they know this fact, right? Before they know this fact, they have already agreed, and everyone agrees with that already. So that's why we say the current flow from positive to the negative poles. Even though after that we realize that okay, we were wrong, that then electron have to go from the negative to the positive, right? But it's already been decided. Everyone agrees already. So that's what they were talking about. Now let's do AC.
Flow are actually opposite each other. In alternating current, the current changes direction periodically.
Compare and contrast now that you know about static and current electricity. Highlight the similarity and difference between the two in the Venn diagram. Download the Venn diagram template, a guide, and compare diagram solution. Static electricity. In static electricity, electrons are transferred between insulator and can build up in some object and then discharge one uncontrollable burst of electron. Current electricity. Electrons flow through conductor for an extended time, usually in a highly controlled way. Both. Both static and current electricity involve electrons. Circuit, component, and diagram. Now that you understand the basics of current electricity, let's move on to explore circuit and their major element in detail.
Mm-hmm.
Circuits are important in understanding how electricity works. In physics, you can draw circuit diagram using special symbols that allow you to predict their behavior in parts of of the activity. You will learn about the part of a circuit and will then see how circuits are constructed.
Mm-hmm.
There are four components in a basic circuit.
Electricity has to come
Source?
from somewhere, right? So
Yeah,
that's the source. It can
source.
be cell or battery. You know, a battery is made out of many cells, right? So when a piece of
Yeah,
battery, you just basically take it out, the covering, you will see that says there's so many small cells in there. Those are small cells inside a battery. There could be up to eight cells, I think. I don't remember exactly. And there are conductors or wires. So electricity has to be conducted some way, right? So those are wires or conductors, anything that conduct it. And then load. The load is basically, it can be anything from light bulbs to any electric device that you use that uses the electricity. So load is something that will use the electricity.
yeah,
And then the switches,
load.
switch on or off, switch on or off, yeah. Right, let's just look at that for a moment. Okay.
Circuits provide electron with a push-up or energy. This energy is referred to as different potential difference or voltage.
Mm-hmm.
The, un- the unit used to measure voltage is the volt V, and it's named for Italian scientist Ale-
Alessandro Volta.
Volta,
Mm-hmm.
who invented the battery in 18,000.
1800.
1800, yeah, sorry.
Mm-hmm.
An example of a source is a battery or a group of battery known as a cell. Electron enter the source through the positive terminal and exit through the negative one. Source can be source can provide either AC or DC, coming from cell, battery, power supply, or wall outlet. Single cell typically produce a potential energy difference or voltage of 1.5
1.5
V.
volts. Like every battery is like a battery, 1.5 volt.
Yeah, that means the electron have 1.5 volt more electrical energy after they leave the cell than before they enter it, explaining why this is called potential difference. Some source in circuit diagram show the positive the plus and the negative minus terminal. It is not indicated the long arm of the cell is positive and the small arm is negative. Conductor or wires. Conductor or wires carry the electron around the circuit. These are usually made of copper and are insulated in a plastic cover. The conductor are insulted to prevent the shock and to prevent loss of electron and electrical energy to the surrounding. Load. The load is the reason the circuits exist. It changed the electrical energy into another form of energy such as heat, light,
It's the
sound,
reason the
or
circuit
motion.
exists because it's the one that uses electricity. It's
Yeah,
the device that you need to plug into the electricity. It's the device. It's the reason why you need the electricity for. It's the device you use. It's called a load. It uses up the energy provided by the source.
change the electricity energy into another form of energy. Load does not the opposite of the source in that it uses up the energy provided by the source. The following table shows some example of different load in household circuits based on the energy conversion. As you can see, many load involve more than one type of energy conversion. For example, clothes dryer use mechanical energy to spin the clothes, as well as heat energy to dry them. Light, light bulb, TV, computer screen, LED, sound, MP3 player, TV or computer audio, portable heater, clothes dryer, dishwasher, toaster, oven, light bulb, mechanical, fan, washing machine,
Anything like
clothes
that, yeah. As
dryer.
long as it uses electricity, these are the sources. And the load. I mean, these are the load, sorry. The source are the one that provide electricity. The load are the thing that consume that electricity. So it's the opposite.
Switch. Switch
Switch control
console control,
flows.
allowing you to turn off the load on and off. A switch can be either open or closed. When it's open, it stops the flow of electron. This means the circuit is not complete, and the load will be turned off. When the switch is closed, the circuit is complete. Electrons are able to flow and the load is turned on.
Simple circuit diagram.
Simplest
This is
circuits you
actually
can
quite fun.
create.
It's actually quite fun to do.
Can create with all four components is made of one cell, a battery,
One
one
lamps,
load.
one light bulbs, one switch, and enough wires to connect components together. I used to do something like this when in the past. Like I built like a small miniature park, and with light bulbs and sources like this. Fun.
Oh, this is layout in the usually circuit diagram. This circuit diagram shows the various components and how they are arranged. Circuit diagrams are usually drawn as rectangle, even though the wires may not be arranged that neatly. This diagram, the circuit is open and there is no flow of electron. If the switch were closed, then the electron would flow through the wires and they would light up the bulb.
As they went through it.
simple circuits containing one source, a cell, one switch, and one load, all joined by a conductor. The components of the circuits are labeled here to help you, but they won't be in the later diagram. Series and parallel circuits. Series cir- Series circuit. In a series circuit, there is only one pathway for the electron to follow. This arrangement is called a series because all the electrons have to flow through all the light bulbs in a series, one after the other. The arrow indicates the point that the electron flow. Remember, the small arm of the source is the negative terminal, and electrons flow from the negative terminal to the positive terminal. These diagrams refer to the flow of electrons, but in a lot of physics work, we can also refer to the conventional current described earlier. Parallel circuit. In a parallel circuit, there is more than one pathway for electron to follow. The simplest parallel circuits have two loads in a parallel arrangement. As shown in the following diagram, each electron has a choice in which path it will travel on. Therefore, half the electron follow a path through the first load and half follow the path through the second lobe. When electrons leave the cell, some travel through the closest light bulb and others flow through the second bulb.
Mm-hmm.
This means that the electrons split up after leaving the cell and then rejoin before returning to the cell.
Exactly. It depends on whether it's like a parallel circuit or is it a continuous circuit. You will see the electron flows differently. For
Yeah,
parallel circuits, they have to split up because they are two direction, right? They have to split up into two. But for continuous circuit, it's just one current, it's just one flow, that electron, so it doesn't split up anything.
cell in series. Here's a circuit with two cells arranged in series. As you can see by the arrows in the diagram, the two shells arranged in series provide only one pathway for electron to follow. The only difference here is the electron have to pass through both sources before completing the circuit. Electrons pick up more energy by passing through two sources instead of just one. If each cell is 1.5 volt,
volt, then you have 3 volt in total.
what would be the potential difference if
Total
there were
difference. The three sources, there were 3 volt each.
3 volt each?
What's your answer?
Answer is
Three
the
sources put
source
together, each of them 3 volt.
3 volt.
So what's the total?
The source
No, it's not there. It just sells in series.
Yeah, wait.
Now look at this one. If you have two sources put together, each of them 1.5. So 1.5 plus 1.5 is 3 volt. Now the
So there
question
would be
is, each of the sources is 3 volt, and you have 3 sources. Should it be 3 times 3? It's 9 volt in total.
and
Is it too hard to understand this? No, it's not.
no, it's not. Just like confused. Why does it say 3 volt each? Is there like a? I was like confused at the like. Wait, what? Why is there 3 volt each? That's the part where I was confused.
Because
So I
each
was like,
source is 3 volts, so 3 plus 3 plus 3 is
yeah,
like 9.
that was like 1.5 volt, but in the
It's like,
thing
it's
just
a
said,
different problem now. It's a different
yeah, it's a
problem
different
now.
problem. Yes, that just confused me a bit. 9V, 3V from source 1. Explore the component of the circuit. This is like
Just a moment, please. Okay, now you play around with this one. It's like you just play around with this one and see the voltage and everything.
uh, so get this. Okay. Cool.
Okay, so now you have 4 batteries. Well,
Yeah.
you should not put that battery directly next to or something that use it. Otherwise it can heat up. A lot.
Heat up.
You
Yeah.
should you should have wires.
Wires.
uh So it's not advisable to just plug the battery directly into something that use the electricity. Not advisable.
Well, I was just testing how the electricity would go if. Light bulb. And then batteries. Oh God. This one. So if you just what happened when you put your hand in like the light bulb?
Say again? If you
So there's
flip
like
the battery in the wrong way, if you flip the battery in the wrong way, it won't work.
oh
You know, if you try your hands there, it won't work because a human body actually doesn't conduct electricity very well. We don't.
oh yeah.
Dogs, it's weird why they do that.
It's just for fun.
Try paperclip.
So paperclip.
Because paperclip is made out of metal anyway, so probably will conduct. Resistor is something that resists the flow of electricity, you know, but still,
Uh,
it conducts some electricity. It still conducts some electricity, even though some amount of that it's absorbed by the resistor.
oh, so it's like uh, oh my god.
See what happening?
So it's like there's like animation speed inflation reduced to
It's explode. You know why?
yeah. It's like too much volt.
When you apply so many batteries there, the load is so much, so it produces a lot of heat. So never overload something.
Never overload. Say that.
Need more wires, I think.
Hmm.
If you have more lights bulbs, it will probably be dimmer because try to have more light bulbs. You will see that the light it's a bit dimmer because it has to share with each other. You know, if you have more light bulbs, but increase the voltage is not a good idea. It's not a good idea to increase the voltage.
Yeah. So if you increase the voltage, everything like
Burns because basically
yeah.
you increase the voltage difference. It means like a lot of the flow is like very strong and it causes a lot of heat.
Cause love heat.
A lot of heat, no joke.
So how many res resistor do you need to like stop from it for stop it from like burn?
Hmm.
Which need? Hey, let's get back. Can I take a break for a bit?
Hmm. All right, let's continue. series and parallel. This is important because most of the thing inside of our home we use parallel circuit.
Parallel circuit. This activity consists of 5 different parts. For all of them, you will need the circuit construction kit. Keep it open in order to exercise. Part 1. Voltage is a measure of the difference in potential electrical energy which occur when a cell or a load. It is measured in volt using a voltmeter. You can use a voltmeter by placing the probe on the either side of what is being measured. If you want to measure the difference it costs to sell batteries, place a voltmeter like this.
I try to be productive today.
Yeah.
Sometimes
So
difficult.
voltage means one circuit choose 9. So it's like
It burned because you have so many batteries now. Or you know why? What does resistance mean? So if the voltage
just
is
like
too high,
that.
of course it burns. The resistance is
Yeah.
basically the ability to resist the flow of electrons. And how does it resist? It resists by eating up that electrons, consuming these electrons, and then when it
Yeah.
consumes it, it creates a lot of heat. It produces a lot of heat. So when you
Heat.
increase resistance, it also creates a lot of heat too. So it burn. So be careful.
Oh my god. It's level.
This is fun to play with. I suggest playing with it more, is to understand it more.
Oh, that's a lot.
That's a lot, you see. So don't expect your your circuit to last if you just have so high voltage.
Number 2, create two circuits. Create one circuit with two 9V cell battery in series and one light bulb. Okay, battery, 9 volt, and one light bulb. Second circuit where the two batteries are in parallel, and there's one light bulb. Parallel. Parallel. Okay. Now measure the voltage across both battery and the series circuits. 18 volt. What was the voltage across the two cell in the parallel circuit? 9 volt, yeah.
You sure about
Comparing
that?
yeah.
Check the answer very carefully, please. You have to understand why it's 9 volt too. Do you understand why? Let's look back at the question. The voltage across the two cells.
Across the two cell. So it's like
Where's your voltmeter? Oh, why it's like that?
yeah, just
Strange. Oh, it's just a repel charger. Because negative repel charger. That's a problem. You must remove one of the thing over there. I think no, I was wrong. I don't know why. Why it's like bending. Weird.
just
Interesting. Okay, should be good enough now.
voltmeter.
Voltmeter. Now across the cell. So from there, yes, another one. It's oh, another one is on the left side of that battery. Yep. Near there. Yes, it's 9 volt now. So
9
that's
volt,
the voltage
yeah.
across the cell we're talking about. That's 9 volt.
9 volt.
Oops, why is it burning? I'll tell you why it burned. Because of the connection between the two cells like that.
Yeah.
So if you remove the
I think it's
connection of the
overload.
two cells, it won't burn. It wouldn't burn. Yeah, that one. Remove it. I don't think it would burn if it's like this. But then, why is it still burning? Just decrease the voltage down.
Please.
There you go. The light is quite dim. You can see. Anyways, 9 volt. Comparing multiple cells in series and parallel.
A create more circuit with 3 or 4 cell battery in series and parallel to compare. What pattern do you notice? Pattern.
fuse gonna burn soon. Okay, let's just try it.
Yeah.
You know, when you have the source like that, the electricity flow has to go back to the battery somehow. Right? So
Oh, well,
if
yeah.
it doesn't flow back to the battery, then the circuit is not complete. So in that way, you have only going, but you don't have something that returning. So that's why I don't think it would work.
Oh,
So
yeah.
so it has to go back to the battery somehow.
Yeah. Well,
And then, yes, that should work. There you go. It's a flow. At least the one battery. But then, let's say it will burn. The switch has to be somewhere in between the wire. Otherwise, it doesn't make sense. The
yeah.
switch there is just useless because it doesn't stop any flow. You have to put a switch somewhere in between the wire. Anyway,
Second
this one
only
is a
light.
waste of time sometimes. It's fun to play with it, but sometimes a lot of the time it's a waste of time, I think.
Well, yeah, it does not burn.
I knew it would burn.
Yeah.
Woo! Guess why?
Yep, you increase the voltage and then it just start to burn.
Just increase the resistance.
Either way, it's too late, I think.
Because there's just too much voltage.
Cell are connected in series. The total voltage of the battery add up. When the
Uh-huh.
cell are connected in
Parallel,
parallel,
the total voltage
total.
stay the same as one battery. You need
Yeah,
to
that's
remember
that's
this
why
one.
it's
When connect in series, of course, when connect in series, battery they just add up. Of course, they plus 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 each other.
yeah,
So the total voltage of batteries add up. But when you connect in parallel, they seems equal to each
parallel.
other, right? They say the same as one battery. But that's when we talk about voltage, okay? Just think about voltage, the difference between the battery. So in series, when you add them up, of course the difference will increase greatly, right?
Yeah,
But when you put them in parallel, the difference between one battery is actually the same difference between different battery too. That's what I mean.
yeah, I understand. Let's see the voltmeter. Says 0. Oh, 9. Yep. So this is a parallel. Measure current, volt, and voltage. As you have seen, current is a measure of the quantity of charge passing through a certain point in a circuit. It is a count of number of electrons per second. Current is a measure in amperes or amps.
Ampere, not amps.
Shortened oh, amp. Shortened to the letter A. Potential difference is a measure
Of
of
the
the increase.
increase in potential electric energy. provided by a cell. So potential difference is voltage. It's a difference between like potential electrical energy provided by the cell. But the current means the flow of electrons. It's the ampere something. These are current and potential difference are two different things, you know. One is A, one is
Yeah.
B. So current is a measure of quantity of charge, like how many electrons pass it through. There's a lot of electrons passing through. How many electrons? The quantity of charge is like how many electrons is the current, you know. So the more electron passing through, of course, the higher or the bigger the current. The count of number of electrons per second. Let's say if the current is like 1 ampere, there should be much less electron compared to like 3 ampere or 10 ampere, right? Makes sense, isn't it?
Yeah. Yeah, that's
Just imagine it like soldiers, you know, into battle. If you have like 10 soldiers compared to like 100 soldiers, that's like a current passing through a bridge, something like that. It's like the number of people passing through a bridge. Have more people, more current. That's the thing. So amps and volts are measured during different kind of meter. You have amp meter and you also have volt meter too. These are the name of the device.
this information summarized in the form chart. Current and potential different volt symbol V. Knowing the amount of current and voltage in the circuit is critical to understand how it will work.
Mm-hmm.
The device known as the ammeter and voltmeter are used to make these measurements. When an ammeter is included in the circuit, it is wired in series and so electron must pass through it so all electron can be counted. Ammeter symbol is a voltmeter symbol V. Using the following interactive activity, you test 5 circuit, describe the table so this is a different one. What pattern did you notice in your experiment? The results show the potential difference is split between the load in the series circuit, but it's the same as the source between load in parallel circuit. What conclusion can you draw about potential difference voltage across the load when they are connected in series versus in parallel? In a series circuit, the potential difference is divided between the load in the different circuits. Potential difference is the same between all loads. Current electricity in your home. Household circuit in North America usually operate on
110 volts. But in Vietnam, it's like 220. For Japan, it's like 110, I think. Taiwan also 110. North America, I mean Canada and America is like usually 110, but the rest of the world is like 220.
There are a few exceptions, such as
So those dryer, central air conditioner, you know why they are exception for these devices? Why we need like higher voltage for those devices? Because they consume much more electricity. That's the thing.
yeah,
Because
more.
you know, stove when you operate it consumes so much electricity. You have to pay a lot of money for stove. For dryer actually heats up, so it heats up so it dry your clothes. So it uses a lot of electricity. It's air conditioner also, you know. So that's why, you know, you pay a lot of money for electricity for these devices. That they need 220 volt because of that. How's your home wire? Is it wire with series or parallel circuit?
How's your home wire? Is wire with series or parallel circuit? Think about what happened when
lights are in when lights are in the same circuit, you must when you must turn on all of them at once, right? Because if you turn on one, you cannot just say I turn on one and I do not turn on the other, because electricity has to flow through all of them, right?
Yeah.
So you either turn on all of them or you don't turn it on. That's how series circuits works. But in parallel circuit, you can choose which one you turn on, which one you don't.
That's true.
You know why? Okay, let me try this one. Okay, let me try this one. Let me try my new iPad function. I've been waiting to try this. Okay, my Apple Pen, please. Okay, and then I need to connect my turn this on. Okay, so basically you should be able to see my iPad screen now. I go to Note, and then okay, let's say that. Okay, I need my Apple Pen now. Alright, so basically, if you have okay, you know what I'm drawing, right? This is like a source. This is a source, and then let's say this is a switch.
Yeah.
Oh my god, my handwriting is terrible in here. Anyway, this is a switch, and then say if this is a light box, this is light 1, and this is light 2. Then if you turn switch on the switch, electric current will flow. Electric current will the electron will flow from this direction through both lights, right?
Oh.
And it goes back into the source, right?
Yeah.
So it means that you can only turn on both lights if it's in series like this, isn't it?
Yeah.
However, if now I draw, say, a parallel, I have a light switch here, and this is a light 1, and moment. I think it should be like this. Because here's like electricity will flow this way, you know. Because I mean the electron flow will flow this way. So it will hit the switch first. It will hit the switch first. However, if I draw another light here, this is, I'm drawing parallel, you see. This is light 2, isn't it? So basically, up on here, the electricity will have to split up into two directions, right? One is going to light 1 and one to light 2, right? You know what I'm talking about?
Yeah.
Because it's split up like this. So basically, if you switch on the switch number 1, which is this one, light 1 will turn on. Because the electricity will just basically now go through this direction, you know. Am I right?
Yeah.
However, light 2 is not being turned on because now the switch 2 is not on. It's off. You know what I mean?
Oh.
So
Yeah. Yeah.
now, each light is independent on each other now. Of course, if I switch on light 2 and I switch off light 1, the opposite will occur, so the electricity will go this way, you know. Know what I mean? And it doesn't go through light 1 anymore. You know what I mean?
Yeah, I understand.
Okay, so in that way, parallel. Wait, is it 1L double L? Parallel. I think it's 1L, okay. So in that way, parallel circuit, you have an independence of the devices. It doesn't have to depend on each other when it operates. However, in series, you cannot just turn on one and then ignore the others. It has to be operate like at the same time, everything, right? Am I making sense now?
Yeah, you are.
Okay, good. That's all I was talking about. All right, stop share. Okay, you can share back your screen now. Please share the right one. Wow, I like this. I like this screen mirroring thing now. Perfect. It's beautiful. I mean, it looks beautiful. Even though my handwriting is terrible, but it still looks beautiful.
That's fine. Circuit loading. Circuit loading. Not all circuits can accommodate the same number of load. The number of load on any circuit is determined by size of the load themselves. Light bulb used in the circuit building activity didn't require or draw very much current. However, one big application client, such as refrigerator, draw of current, so it can't share circuit with other big applications. Most household circuit can handle a maximum of 15A. Several bedrooms in the house may be on the same circuit. I mean all the wall outlet and ceiling fixture are on the same circuit. If all the light are on and all the outlet are in use in the bedroom, you may come close to the 15 maximum. A maximum.
Maximum is 15 ampere.
Yeah.
So it means like if you have more electric current than 15 ampere, the device will burn. Several bedroom and house may be on the same circuit. Come close to 15 ampere maximum. Why is it might be better to use a hairdryer in the bathroom instead of bedroom? Okay, using this knowledge, can you answer that question? Why is it better to use a hairdryer in the bathroom instead of bedroom? What do you think?
Um. Well, when you use in the bathrooms, like that's where you most likely where you take a shower and you can just use it to a faster
Okay, because of
way to.
conveniency, yes, but we're talking about electricity now. So why is it better to use a hairdryer in a bathroom instead of a bedroom? Okay, so basically bedrooms, um, or several bedrooms in a house maybe send the same circuits. So basically, if you use a hairdryer in the bedroom, it's in the same circuit. So basically, other people in other bedrooms are using some other things. It might not be so good for them, because you're eating up a lot of electricity by using a hairdryer. So other devices in other bedroom may turn off because they're using the same circuit as you.
Yeah.
But when you use bathroom, it's not on the same circuit, so basically it doesn't affect the other people. Okay, so look at the reason. Bedroom circuit may not be able to supply the current needed by the hairdryer on top of all its other loads. So it means like if the other people are also using something in their bedroom as well, you might not have enough electricity to use your hairdryer. So your hairdryer will run like very slowly or not so good. The second reason is that bathroom is often on its own circuit, so it's separated. So there are fewer loads on the bathroom circuit. You don't have to share with many people or anyone at all. So your hairdryer will be very strong, because of that.
Oh.
Have you ever see like if you're in a kitchen and then you turn on the electric kettle to heat up water, electric kettle.
Yeah, I know that.
And then when you use the microwave oven at the same time, and when your mother is using the electric oven at the same time, then the CB, the circuit breaker will be like beep, 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 beep. It turn off, right?
Yeah, turn off.
Because why? Electric oven, kettle, water kettle, or a microwave oven, they are all consuming a lot of electricity. And when you exceed a certain load, the CB or circuit breaker has to turn off to prevent burning, to prevent accidents.
Excellent.
Because you don't want so much current to flow through your house. Otherwise, thing will burn, thing will be destroyed. So CB is a thing that kind of save your devices. The circuit breaker.
Circuit breaker.
You don't want bad thing to happen.
Yeah, so
Mm-hmm.
heating up. Circuit breaker. Yeah, here it is.
Oh, there you go, circuit breaker.
Yeah. Circuit breaker
Gauchi.
is its home to protect them from excessive current.
The
Some homes
Gauchi
they
circuit is the circuit breaker.
Cow fuse.
Some homes they
Many
use an older
modern
technology called a fuse. A fuse is in Vietnamese cầu dì. The inside is made of lead, so dì. It's made of lead wire.
lead wire.
So why they are made of lead? Because lead has a lower melting point, compared to like copper wire. So basically, when you have so much current flowing through your wires as a whole, it it basically melt the lead, and because when the lead melt, it breaks, and then the circuit become not whole again. It becomes like broken, so no more electricity flowing through your house. So in that way, it prevents house fires, because too much electricity. But the problem is, you have to find a replacement fuse, and that is very annoying. So now we have something called circuit breaker, which can be turned on again and reused. That's a new technology. Not so new. It's
Yeah.
been around for like 40, 30 years, I think. So you can reuse it. Beep, 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 beep. You just turn it on like that. Doesn't burn out when too much current passes through it.
Household wire. Household conductor in North America usually contain three wires under plastic insulation. A cut view of household wire revealing how it is made of three separate wires wrapped together in a plastic bag coating. Each wire serves a different function.
Black
Black
wire, hot wire, dây nóng,
carrier
hot wires, dây nóng, dây nguội, hot wire, cold wire. Electron with greater potential, the white wires to cause a neutral wire. So basically, one is like carrying the current from the source to your device. Is the black one, the hot wire. But then, of course, to make the circuit, close, you must have a way to lead the current back into the source, right?
Yeah.
So you need the white wire to lead the current back into the source, back to the source. That's the white wire. And you need a third one, which is called the bare copper wire. So the copper wire does not have anything covering it. It's bare, and it's called a ground wire. It protects you if there's any excess electron in the wire or device by doing the same thing it did in static electricity example. So it doesn't cause like ouch, static electricity. So it leads the excess electrons back into the earth. So it carries extra electron away from you and into the earth. So it helps save people or devices in case they are static electricity.
Oh,
You don't want to touch something and then ouch! It's annoying.
yeah.
Okay, it's near the end of it. Let's finish that.
Yeah. It's almost done. Let's see. Home edit. Notebook. Do an audit of your household and or workplace, checking the overloaded circuits. What recommendation might you make to fix them? Record in your notebook. You may wish to draw a diagram of your home or workspace to support the expedition. Explanation. That's that's it for 4.2 creating electric circuit.
Okay, I think that's it. Let's end the lesson
Yeah.
here then. Okay, that's the end of my videos. Please like, share this video with your friends, subscribe to my YouTube channel, and press on the bell button next to the subscribe button so you can get notified about my new uploads, okay? You can also press follow my Facebook, but please don't add me on Facebook as friends, okay? Cảm ơn các bạn đã theo dõi nha. Các bạn hãy nhấn vào like, chia sẻ video này bạn bè các bạn. Nhấn vào nút đăng ký kênh YouTube mình và nút cái chuông kế bên cạnh cái đăng ký kênh á, để mà các bạn có thể được thông báo về những video mới nha. Các bạn cũng có thể nhấn vào nút theo dõi Facebook mình, nhưng nhớ đừng kết bạn Facebook mình nha. Thank you and see you. Bye.